Last video in my technical videos, I just wanted to add a couple more points. First of all, I guess people are wondering, what is the SQL statement logic behind determining your buy item and sell item? So I'm just going to show that real quick. Go back to my database class. And you see right here, this SQL statement. I'll scroll through it very slowly. It took me a couple hours to figure it out, but this statement is what I'm using to separate the lowest priced item and the highest priced item in the database. I give some credit to Stack Overflow for helping me figure this one out, but this is the statement. You can see I've casted the median value, which is my price value that I'm comparing between the lowest and the highest over an average of 14 days. That is the main value I'm using for comparison. And the reason I have to cast it is because on the website it's brought in as a string and I have to convert it into a decimal to allow my SQL server to compare the prices. But okay, so once the values have been compared, the class it's going to output an array list. See, the very end outputs an array list, and same with the the buy value and the sell value, they both output an array list. So items 2, I believe that's the sell value, and then items 1, that's the buy value. So both are outputting an array list. And that's just what you saw in the GUI for what servers were recommended to buy from and sell from. So if we have concurrent users using this server at the same time, we need to have synchronization mechanisms in place. And our results are stored in a hash table. This is the Arrayholder class. So we have a concurrent hash map here. The reason why it's concurrent is because multiple people might be doing the same calculation at the same time and storing in this hash map. So a concurrent hash map allows people to write to the hash map their results at the same time. And our array list, set items 1, that's our buy values, and then our so the servers we should buy items from, and our array list 2, that's our the servers we should sell the item on. And I stored in a hash map, a concurrent hash map, and the results are stored in IP address key value stores. The reason why I'm doing that is because each user has their own unique IP address, and the result will be then stored via IP address into the hash map. And multiple users can do this because the concurrent hash map allows multiple writes at the same time. That will just queue them all up and then write to that hash map when appropriate. So that's our synchronization. It's already been written for us, and it's in that concurrent hash map. So one last thing, the main class where our user threads are running, you can see at the end of the run, when the user thread's about to be done, we're going to write our results to the hash map. So let me pull that up real quick. So yeah, the end of the run method. Here's our run method. At the end, we should be storing the results. But yeah, we call the run method, so it's going to be the end of the run method. Yeah, so this is our buy values that's being returned. You can see it's an array list that's being stored in the hash map. And then our sell values, they should be being returned as a hash map or array list as well. And you can see they are from the end of the get list too. And then back in our main run method, or just our run method period, we'll be storing the results. So run's right here. This is run. This is the main method that runs the whole application. You can see at the end I'm sending our list results, our buy and sell values, to our GUI, and they're being stored in the Arrayholder class, which was the one with the concurrent hash map. So we are placing the results from run method and get list to our buy list and our sell list. We're storing it in that concurrent hash map according to IP address. And that IP address was provided by the client via the socket connection. And we went through that earlier. But basically, every time a user thread is started, it's going to get its IP address in the constructor through the socket that connected to it. And each socket is going to have a different IP address, and that's going to be placed into our variable, the IP address variable, final IP address, and that is going to be the key value for the results storage in the hash map, which then will be accessed again by the client in the client logic. And basically this allows multiple people to write to the hash map at the same time, but still access their individual catch result data in the hash map by their IP address. And this promotes concurrency and allows hundreds of users to run the program and store the results in their own unique catch, which will be accessed by their IP address. Now, it doesn't have to be an IP address. We could do it by account number, username, etc. I just chose IP address because that's just what I decided in my design. But the point here is that hashmap is promoting the concurrent use. Every user has their own unique ID, and in this case, it's the IP address. So I hope that clears things up. Concurrency was promoted through immutable object, each user having their own file system created by their IP address, and this hash map key value retrieval system. So that's how I've been promoting concurrency in this application. I hope this makes sense. If you have any questions, feel free to email me at kvburke@ncsu.com or ncsu.edu. That's all I have to say for today. Thank you for watching the video.